Hello guys, welcome back to the video. So today we are going to see problem number 498, diagonal traverse. So given a MN matrix mat, return an array of all elements of array in a diagonal order. So as you can see in this example, we have to move diagonally in a zigzag way in this 2D matrix. So you can see this one, then we are going to 2, 4, 7, 5, 3, 6, 7, 9, and we have to make an array of that and return it. So you can see this. So hope you get the problem. The problem is clear. Let's see the constant. M equal to mat dot length n equal to okay 1. So the maximum length of mn will be 10 raised to 4 and m into n will be 10 raised to 4, and mat of ij can be anything. So we don't care about ij because we're just moving, traversing and making an array of that. Okay, so let's see few observation first. Okay, in this, so we have the same array, correct? So one time we have to move like this in the upward direction, the other time we have to move in the downward direction. We have to repeat the same thing. Okay, like this. Okay, and we just have to make an array. So the array size will be m into n. Okay, m into n, because it will contain all the boxes of that 2D matrix. Okay, so what I can think is, as of now, we'll just start from all these indexes. Okay, all the corner indexes, this L shape, and do a upward traversal like this, only like this. Okay, once we do this, second also we do this. Okay, and if you can see the pattern, once we need the upward traversal, other time we need a downward traversal. So what we can do is, when we are doing the second, fourth, or the even traversal, we'll just return a reverse of that thing. So like we add first 4. Okay, the second was 4 comma 2, so we'll reverse it and add it 2 and 4. Okay, then we have 7 5 7 5 3, so we'll add as it is 7 5 and 3. Then we have 8 and 6. Okay, I'm talking about this diagonal. This one diagonal contains these values, so we'll add 6 comma 8 because it is even, so we are reversing it. Okay, and then I will add 9 at the last. So in this way we can construct the whole array. Okay, hope you get it. It's simple. We are just traversing through each point, each endpoint, and doing upward traversal and keeping a boolean. We can take a boolean for if it's odd or even. If it's odd, we'll add it is, and if it's even, then we will do a reverse and then add it. Okay, so hope you get it. Let's write a code for it. Okay, so first we'll take and the answer equal to, I will little zoom in so that you can guys see, and the answer equal to new int. Okay, okay, before that I'll make int row equal to mat dot length, and the column equal to mat of 0 dot length. Okay, so here int will be r into c. We have this much elements. Okay, so before that we'll make one helping function. Okay, public, it will return list of integer. We'll take list of integer as of now. Okay, so list of integer it will return, and help, we'll write help. In that we'll give the indexes, the initial indexes, that is 0 0 0 1 0 2, like that, and then 1 2 and 1 2 2, like that. So we'll give these indexes, we'll traverse through it, and that will compute us all the diagonal values and give us that this helping function will do. Int I comma int j comma int mat comma int sorry, I not int, it will be boolean. It will tell us like the diagonal is going upward or downward. Boolean odd we will give. Okay, whenever it is odd it is moving upward, whenever it is even it is moving downward. Okay, hope you get it. So we'll write while i's. So in this case, we'll every time be moving upward. So for moving upward, I should be greater than equal to 0 and j should be less than mat of 0 dot length. 0 dot. Okay. So we'll be moving upward only. Just the returning part, we will reverse it. Okay. So I'll show you how we'll reverse it. We'll not actually going to use reverse in this. Okay. So if odd, if it is odd, okay, I forgot to make an list of integer current equal to new linked list. Okay, I'm using linked list. So if it's odd, current dot add as it is. Mat, I've not given this. Okay, mat of ij, sorry, inj, correct. And else, if it's not odd, I'll do current dot add first. Okay, I will add in the first. So whenever I traverse to this, okay, let me show you. If I'm at 4, okay, if I'm at 4, then it will be added. So now the array list have only 4. Then I will add 2. I'll add 2 at the beginning, not at the end, because we want to reverse it, right? So I will be keep on adding the things at the beginning and I will get a reverse array like that. So instead of doing reverse, I'm using this logic. Hope you get it. Okay, then uh, I am minus minus because we are moving upward and j plus plus. That's it. And we'll just return this. Return current. Okay. Our helping method is complete. Let's write our loop. Okay. So once we will iterate for all the rows, then for the remaining columns. 1 to 0, I should be less than row I plus plus. So here we'll get an list of integer as current equal to help I comma 0. J will be always 0 as we are moving through the first line. The column will be 0 mat comma odd. Okay. And if odd, we have not declared odd, we'll declare it boolean odd equal to true. Okay. Initially our odd is true because the first element will moving upward. So if it's odd, we'll just make it odd equal to false. And else we'll make it odd equal to true. Okay. Hope you get it. Then what we'll do, we'll just take another loop t j equal to 0, j should be less than current dot size. We'll take this element and paste it there. Answer of x plus plus equal to current dot get j. Okay, and we'll make an index also x equal to 0. This is for the our answer array index. It will keep a note of that. Okay, then we'll just return answer. Okay, hope this is clear. Let me check the logic. Okay, one part is remaining. We have to do for all the columns also, right? So I equal to 1. Instead of row, I will write column. And instead of this will be I, and this will be row minus 1. So we will be iterating to this also, but we'll not include this. We'll start from 1 and this 2. We'll covering this. Okay. Okay, that looks good. Let's try to run it. Okay, it's working. Okay, so hope you get this question. So here the time complexity will be big of mn, okay, and space also same big of mn. Or we can take a diagonal, but let us take big of mn only. Okay, So there is also a better way to do it. I'll just show you. So hope you get this part. This was the simple part. Okay. The other way is just iterating through how they are showing in this diagram. Just iterating through how they are showing in this diagram. So this is a bit confusing one. So I'll try to explain you. Okay. So I'll just remove this part first. Just removing this. I'll take this example again. Okay. So initially, I will give you a logic. Okay. First will be on this index 0, 0. Okay. Then we have to move. We will be doing a upward climb. Then we have to move to the 0, 1 index. Okay. And then we'll do a downward climb, or we'll do a downward iteration. Then we'll reach here. Correct. Then we will start from here. That is 0, 2, 0. Sorry. Okay. Then we will again climb back. Then we will start from here. Then we'll start from here. So how many are our starting points? We just need to find that. So this is the one. Okay. This is the second. This is the third. This is the fourth. And this is the fifth. So we all need these starting points. So we know we have a boolean to show which direction to move. Okay. So we'll move like that. So let's do one thing. Okay. So first the iteration is 0, 0. Okay. We added that part. Okay. We're taking this one. Now we will see what we have to do. Now the direction was upward. We're going upward. Okay. So we'll consider the column here. Okay. So you can see if the column is not equal to the index, that is 2. We know that column is 0 only, right? Initial, and it is not equal to 2. So we can move that column to one step ahead. Okay. So column, this is row. Okay. The column will become 1. Okay. In this case, when we are moving upward. Okay. And what about the row? So row what will do? Row also, row will be 0 only. Will not move the row because the column has not become 1 as of now. Okay, I will show you this one. Okay, now we'll start from 2, we'll go to 4. Okay, so at 4 what we have the index. I'm just showing you this iterations how we are going to do it. Okay, so at 4 we have index 0, 1, 0. Sorry, row will be 1 and column will be 0. Got it? This one I'm talking, this one. I'll just remove all this and just show you back again. Okay. Initially we have covered. So this is row. This is column. Initially we are at 0, 0. Now we have to move to the next part. So for that it will be 0 and 1 because we can move the column. Okay. Here we are not reached to -2. If we are not able to move the column, we have moved the row. Okay. Now we are going downward. Okay. From this. So now our row and column is 0 and 1. That is value is 2. And we are moving downward. We'll reach to 4. Okay. We'll reach here. Okay. And our column and row will be what? 1 and 0 because we are moving downward. Okay. This is for 2. This is for 4. After 4, we'll be out of bound if we go just down. Okay. So we need to find a new index to start. So now in this case, as we are moving downward, we'll see the rows. Okay. Is there a scope that I can increase the row? Yeah, there is. So I will just increase the row to 2. And if I increase the row, I have no need to increase the column. Column will be same only. I can use the same column because for that same column, one row was remaining like that. So like that, we have to think and do it. So let's take the next iteration. Okay. So from 7, we'll reach 3. 3 will be 2, 2. Okay. Sorry, 0, 2. So again, row and column here will be 0 and 2. Now we're moving upward. We'll consider the columns. Okay. So can we move the column to the right side? If I move, it will be 3 and it will be out of bound. So no, we cannot move that. So we'll just keep the column same as it is. Column will be same as it is. Okay. And now in this case, we have to move the row one step down. So we'll move the row to one step. So you can see we have reached to this 1, 2. Okay. So now from this 1, 2, we'll go down to the 8. 8 will be row will be 2 and column will be 1. So row, column will take again, row will be 2, column will be 1. So now we are moving downward. We'll see that we can move the column again by one step to the right. Yeah, sorry, when we're moving downward, we'll see the rows. Okay, can we move the rows one step down? No, we cannot move. So we'll take the rows as same and we'll increase the column. So column will be 2 and we'll start our iteration in the upward direction, and in this way we completed and reached to whole zigzag. Okay, hope you got it. So let's if you want, you can try for some time by writing the code yourself, or you can follow with me. Okay, I'll just erase this and write the code for you. Okay, so similarly as we did for the int, right? So we'll take anti answer. So first we'll take row equal to mat dot length, anti column equal to mat of 0 dot length. Okay, and we'll take anti answer. Similar to the previous solution, we are doing the same things. Okay, anti answer equal to new int row into column. Okay, and we'll take an index. Let's give idx equal to 0 index for it. Okay, and what we'll do, we'll write a function while we want both index inside. Okay, while I is less than r and c is oh sorry, not c. I've not written int I equal to 0. I can write row and column. Okay, row, and so it will be easy to understand. Initially both will be 0. So row should be less than row dot length and column should be less than column. C, only C. Okay, hope you get it. We are going to traverse now. Okay, so initially our things are valid. So we'll just add answer of idx plus plus equal to mat of row and column. Row and column. Okay, so we're done with this. We just added to row and column. Okay, now we'll check the next thing. Okay, if we are able to move it or not. So int new row equal to, so if we are moving forward, like, oh, we have forgot to make the direction part. Int dirct, okay, equal to 1. I'll check the direction as 1. 1 means upward, and if it's not 1, then means we are moving downward. Okay, equal to 1. We are using a ternary operator here. If it's 1, okay, so we'll just do row plus. If it's 1, then we're moving upward. So what we have to do with the row? We have to do a -1, okay, or 1. Okay, got it. And int new column equal to col plus the same thing, but just the reverse. If we are moving upward, we'll doing the column +1. So if 1, then +1. If not, then -1. Okay. Now, if these things are out of bound, what we have to do? Our loop will end. So we'll just correct the, means, see, when we are here, okay, now suppose we are here, okay, and if we calculate the new column, new row, it will go somewhere here, and we don't want that. So we need to correct it and bring it here. So for that, we'll write the code now. Okay. So if new row is less than 0, first thing, or new row is equal to row r minus 1, r, let's take it equal to r, and similar for column also. new call is equal to is less than 0 means it should not be out of bound. Basically, we are writing that new call is equal to C. Okay, it should not be out of bound. That part we are writing here. So suppose if it's out of bound, so we have to calculate the new start point. Okay, I showed you. So if the dir city direction is equal to 1, then we'll consider what we'll consider. We'll consider the columns. Okay, so the row plus equal to, we'll just add, right? So if we are on 1, okay, and we are able to move that column to the right side, we'll just do that. Okay, so for that we'll write another ternary conditions like if column is equal to C minus 1. Okay, if column is at the end, we cannot move that. Okay, then we have to move the row. Okay, so for that we'll write 1 or we'll write 0. Hope you get this. Say for column equal to if column is less than C minus 1. Okay, question mark. If it is less than C minus 1, we can definitely do add 1. Okay, so hope you get these two lines. Okay, see if when we are moving upward, we'll see if we can move the column. Yes, we can move that. So we no need to add anything into the row. So if column is not equal to C minus 1, then only we are able to move the column. So we are adding 0 in this case because it's not equal to C minus 1. And if it is C minus 1, then we will be adding 1 to the row. Then the row will shift down like that. And for same for the column, if we have a scope to increase the column, we're just increasing it by 1. I'll write a else also for this. So this case for moving downwards. Okay, so while moving downward, what we will check, we will check that if row we can move. Okay, so instead of column we will do row. Row r minus 1. If rows are equal to r minus 1, sorry, row should be less than r minus 1, then we'll increase 1 or column. And here also same, if row is equal to c minus 1, then we are increasing column or not. Yeah, correct. So we got this condition. Then dirct. So after every iteration, after so we will flip the direction. Okay, 1 minus dirct. So every time we'll flip it. Or okay, also flipping will be inside this. Okay, when we will be out of bound, then only we are flipping it. Otherwise, we'll continue with that. Like we'll write else also. Else we are not out of bound, then row equal to new row and column equal to new column. Okay, so in this way, and we'll just return the result. Okay, hope you get it. It's little difficult to understand. You need to practice it. Just write down this matrix and with the iterations given, right, with the formula I've shown on the screen, just go through it so you will get it easily. I'll just try to run it. Okay, okay, this one I did a mistake, and also I think I'll return the answer. Okay, yeah, that is fine. We're getting something wrong. Okay, let's check it why. So we're getting one wrong answer. Let's see, let's diagnose what's wrong in this. Okay, so mostly it will be here only. Okay, I got it. So here if you see, we are just updating the row, and in the second thing we are taking that condition. So row is getting updated, and that's why we're getting wrong. So first we have to update the column here and then row. So I think it will work now. Yeah, it's working fine. Okay, so here the time complexity will be big of mn. mn, and space, we are not using any extra space, we are just iterating zigzag, so it will big of 1. So hope you like the video. If you have any doubt, please comment down, I will try to help you. Thank you.